Everything you think you know about Megalodon is wrong. Not slightly wrong. Not outdated by a minor detail or a revised fossil date. Wrong in the way that matters most, the image you have carried in your mind. The creature you picture when you hear the name, the monster that has appeared in films and documentaries and Shark Week specials for the past 3 decades. That creature did not exist. The real Megalodon was something else entirely, something stranger, something that once you understand what it actually was, makes its extinction far more unsettling than any version of the story you have heard before. We are not going to describe a giant great white shark, we are going to describe what the science actually says. And by the time we are finished, the question will not be whether Megalodon was terrifying. The question will be whether we have ever truly understood what we lost, and what that loss tells us about how fragile even the most dominant things can be. Let's begin with the lie. For decades, every reconstruction of Megalodon started from the same assumption. Take a great white shark, scale it up, add mass proportionally, give it larger jaws, a heavier body, a more imposing silhouette. The result was a creature that looked like a great white inflated to the size of a school bus. What a stocky, slow-moving, a predator that dominated by sheer mass rather than speed or agility. That image appeared in textbooks. It appeared in museum reconstructions. It appeared in Hollywood films that generated hundreds of millions of dollars at the box office. It became, for most people alive today, the definitive visual representation of the largest predatory shark that ever lived. It was built on a fundamental error. For most of the history of Megalodon research, scientists had almost nothing to work with except teeth. Shark skeletons are made of cartilage, not bone. Cartilage does not fossilize easily. It decompresses, dissolves, disappears over geological time. What survives are the teeth, dense, mineralized, extraordinarily durable structures that preserve for millions of years in marine sediment. Megalodon teeth have been found on every ocean floor in the world. Some exceed 18 centimeters in length. They are unmistakable. But a tooth tells you very little about the shape of the animal that carried it. The reconstruction of Megalodon as a scaled great white was not based on skeletal evidence. It was based on the assumption that because the two animals shared certain dental similarities, they must have shared body architecture. That assumption shaped every visual representation of the creature for generations. In 2024, a study led by paleobiologist Dr. Kenshu Shimada at DePaul University, published with a team of international researchers, used new biomechanical modeling, comparative anatomy, and the rare fossilized vertebral columns recovered over the years to produce a revised body reconstruction of Otodus megalodon. The result dismantled the image entirely. Megalodon was not a scaled great white shark. It was long, slender, and streamlined, proportionally closer in body shape to a large mako or a lemon shark than to the wide-bodied predator that had been depicted for decades. The revised length estimate reached up to approximately 24 meters, longer than a blue whale, the largest animal alive on Earth today. But that length was carried in a body that was far less massive than previous models suggested, leaner, more hydrodynamic, built for sustained movement through open water rather than ambush from a static position. This was not a creature that sat in one place and waited. This was a machine built for oceanic migration on a global scale. Think about what that revision means for everything that followed. A slow, wide-bodied ambush predator and a long, streamlined, open ocean hunter are not simply different shapes. They are different ecological strategies, different prey selections, different metabolic demands, different vulnerabilities. Understanding what Megalodon actually looked like changes. What it ate, how it hunted, why it died, and why it absolutely cannot be hiding in the deep ocean today. Each of those questions leads somewhere darker than the one before it. Let's start with what it ate, because the numbers involved are almost impossible to hold in the mind. Megalodon was a mesotherm, not fully cold-blooded like most sharks, and not fully warm-blooded like mammals. Its internal body temperature ran warmer than the surrounding water, which allowed faster muscle function and greater sustained speed, but it also meant that the metabolic cost of simply existing was substantially higher than a cold-blooded animal of equivalent size. A body 24 meters long, running warm, moving continuously through open ocean, required fuel on a scale that has no real comparison in the modern ocean. Estimates for Megalodon's daily caloric requirement converge around 98,000 kilocalories per day. To put that in terms that register physically, a large adult male human in good physical condition requires roughly 2,500 kilocalories per day to maintain his body. Megalodon required approximately 40 times that amount every single day without exception. Not weekly, not when it happened to find prey. Every day the body demanded 98,000 kilocalories just to maintain itself at rest. And this was not an animal that rested. The prey capable of delivering that caloric load in a single feeding event was not small fish or squid or the kinds of animals that populate the deeper ocean. It was large marine mammals, specifically whales. The fossil record from the Miocene and Pliocene epochs, the period between approximately 23 million and 3.6 million years ago, during which Megalodon existed, contains abundant evidence of its feeding behavior. Whale bones from this period carry cut marks, punctures, and impact fractures consistent with Megalodon attack. The force required to produce those marks has been calculated from biomechanical modeling of the jaw architecture. The bite force of Megalodon is estimated at approximately 18.56 metric tons of force, the highest of any animal for which we have a calculable estimate in the history of life on Earth. For reference, the bite force of a large great white shark is roughly 1.8 metric tons. The bite force of a saltwater crocodile, the most powerful measured in living animals, is approximately 1.7 metric tons. Megalodon bit with 10 times the force of a great white. A single strike from those jaws, delivered into the rib cage of a large whale, was capable of fracturing the ribs and collapsing the chest cavity before the animal had registered what had happened. The attack was not prolonged. It was not a chase ending in exhaustion. It was a single catastrophic strike from an animal moving at speed in open water, followed by consumption. The ocean during Megalodon's era was, in a very literal sense, organized around this animal. Its presence shaped where whales traveled, where they gathered, where they could afford to surface. It was not a predator within an ecosystem. It was a structural force that the ecosystem had organized itself around, and then in geological terms, almost instantly it was gone. But before we get to the extinction, we need to address the question that generates more online discussion about Megalodon than any piece of fossil evidence ever has. Is it still alive? The answer is no. But the reason why is not what most people expect, and the logic of it leads somewhere genuinely strange. The most common version of the argument for Megalodon's survival goes like this. The deep ocean is largely unexplored. The Mariana Trench descends to nearly 11 kilometers. We do not know what lives at those depths. Therefore, a large predator could theoretically persist there undetected. This argument has a surface plausibility that makes it emotionally satisfying. And it is wrong in a way that is almost mathematical. If you watch the Mariana Trench video on this channel, you already know what lives at the bottom of the deepest place on Earth. You know about the amphipods, the snailfish at 8,336 meters, the microbial sediment communities, the marine snow that falls for days to reach the floor. You know what the Hadal Zone actually contains. And precisely because of that knowledge, the impossibility of Megalodon surviving there becomes physical rather than theoretical. Start with the calories. 98,000 calories per day. The Hadal Zone, everything below 6,000 meters, is one of the most energy-sparse environments on the planet. The primary food source is marine snow, fragments of dead material drifting down from surface waters. The animals that survive there are small, slow metabolizing, and adapted to function on minimal energy. There are no whale populations at Hadal depth. There are no large marine mammals anywhere in the deep ocean capable of providing a caloric load sufficient for an animal of Megalodon's metabolic demands. A single day without adequate feeding would begin a deficit that the animal could not recover from. Sustaining that deficit for the millions of years since the Pliocene is not biologically conceivable. Then there is pressure. Megalodon was built for open ocean at moderate depths. The warm, shallow, prey-rich waters of the Miocene and Pliocene continental shelves and open seas. Its physiology as a mesotherm, its body architecture as a streamlined surface predator, its gill structure. None of these are compatible with the pressure conditions below 2,000 meters. The deepest documented sharks are specialized species adapted over evolutionary timescales specifically for those conditions. Megalodon was not one of them. And then there is simple visibility. An animal 24 meters long cannot move through the world ocean without being detected by the density of acoustic monitoring, sonar systems, marine research vessels, and submersible programs that have operated continuously for the past 60 years. Every significant large animal in the ocean has been documented. The idea that one of the largest predators in the history of life has persisted undetected through the age of satellite oceanography and global acoustic monitoring networks is not a gap in our knowledge. It is a physical impossibility. Megalodon is not in the deep ocean. But something happened in 1918 that is harder to dismiss than it should be. In waters off Port Stephens, Australia, a group of crayfish fishermen reported an encounter that was recorded at the time and has remained in the historical literature ever since. The men described a pale, ghostly white creature of enormous size. Some accounts place it at over 35 meters, that approached their boats and lifted their crayfish pots, which weighed several hundred pounds each, as if they were weightless. The men refused to return to the water. Several refused to discuss the encounter in detail afterward. The account was collected by naturalist David Stead, who interviewed the fishermen directly and documented their descriptions in 1963. He noted that the men, experienced, practical, ocean-hardened workers with no known motive for fabrication, were genuinely distressed. Not excited, distressed. The scientific consensus dismisses this account as misidentification, a whale shark perhaps, or a large specimen of another known species seen under conditions that distorted perception. That explanation may be correct, but it is worth sitting with the fact that men who worked the ocean professionally, who knew what a whale shark looked like, and who had no cultural incentive to invent a sea monster story, described something that troubled them enough to refuse to return to the water. We dismissed it. Of course, we dismissed it. The question is only whether we dismissed it because the evidence was insufficient, or because the alternative was too uncomfortable to hold seriously. Now let's return to the extinction, because this is where the real story lives, and it is not the story that gets told. The version most people know goes like this. Megalodon went extinct approximately 3.6 million years ago because its food supply declined. Climate change reduced prey populations. The animal starved. It died. That version is true in its broad outlines, but it is missing the element that makes the story actually matter. Megalodon did not die because it was weak. It did not die because it was outcompeted by a faster, smarter, more adaptable predator. It did not die because of a disease or a catastrophic event or a random biological failure. This is not a story of simple loss. Megalodon died because it was too perfectly adapted to a world that no longer existed. In the Pliocene epoch, as global temperatures fell, the ocean reorganized itself. The warm, shallow, biologically rich seas of the Miocene. The seaways and continental shelf environments where large baleen whales gathered in the warm water that supported their prey began to contract. Whale species that had lived in warm, accessible nearshore environments migrated toward cooler, deeper polar waters as ocean's temperatures dropped. The distribution of the large marine mammal biomass, which had been concentrated in the warm, coastal zones where Megalodon hunted, shifted to environments colder and deeper than the animal was built to exploit. The ocean had fundamentally reorganized. Megalodon's 98,000 calorie daily requirement was not a problem in the Miocene. The ocean was organized to support it. Warm water whale populations were dense, accessible, and geographically concentrated. In the Pliocene, that organization collapsed, not slowly. In geological terms, it collapsed rapidly, over a window of perhaps a few 100,000 years. And because Megalodon's entire physiology, its body size, its metabolic rate, its hunting strategy, its prey selection, everything was calibrated to a specific ocean condition, the animal had no adaptive flexibility. It could not shrink its body to reduce caloric demands. It could not switch to a different prey type in sufficient quantity. It could not follow the whales into colder water without the physiological architecture to function there. The species had no room to adapt once its world changed. The most lethal predator in the history of the oceans was not brought down by a rival. It was brought down by specialization. By being so completely, so perfectly optimized for one version of the world that when that version ended, nothing of it could survive. This organism bit with 18.56 metric tons of force. It crossed entire ocean basins on migration routes. It organized the behavior of every large marine mammal always during its era. It left teeth on ocean floors around the Earth. It persisted for nearly 20 million years. Gone. Not because it lost a fight, because the world it was built for stopped existing. There is something in that story that extends beyond paleontology. The greatest vulnerability of any system, biological, ecological, civilizational, is not weakness. It is absolute optimization for conditions that can change. The things most perfectly designed for one world are the things most completely destroyed when that world ends. Megalodon was perfect. That was the problem. We have spent decades getting this animal wrong. We gave it the wrong body. We gave it the wrong hunting strategy. We told the wrong story about its death. We invented a mythology around its possible survival that was more comfortable than the actual truth. The actual truth is stranger and more instructive. It was 24 meters long and lean. It crossed oceans. It required 98,000 calories a day. It bit with a force that nothing alive today approaches. It was not slow. It was the fastest large predator of the Miocene Ocean. And it was so deeply embedded in a specific configuration of the living world that when that configuration shifted, the entire animal became impossible. There is no version of the Megalodon in the deep ocean. The physics of that environment make it a non-question, but the ocean keeps producing reasons to remain uncertain about what it contains. The fishermen at Port Stevens were not scientists. Their testimony is not evidenced by any rigorous definition. And yet they saw something in 1918 that they could not explain. In water we have never fully mapped, in a region of the ocean that remains, even now, incompletely surveyed. We have been wrong about Megalodon for a long time, not about whether it is alive. That question has a clear answer, but about what it was, about what it tells us, about what the ocean is capable of hiding, not in its depths, but in its history, in its biology, in the gap between what we assume and what is actually there. Megalodon reminds us that we have been misreading the ocean for decades, that the largest predator in the history of life was walking around in our textbooks with the wrong body, the wrong behavior, and the wrong extinction story. If we were that wrong about something that left 18-centimeter teeth on every ocean floor in the world, what else are we misreading? What else is the ocean showing us that we are not yet seeing correctly? That question does not end with Megalodon. It is only the beginning of it. The largest predator in the history of this planet did not disappear because it lost. It disappeared because the ocean changed, and it had no answer for that. 60 tons of precision, 18 tons of bite force, a jaw that could fold a whale in half. Gone. Not because it was weak, because it was perfect for a world that no longer existed. We spent decades drawing it wrong. A movie monster, slow, inevitable, and the entire time the answer was in the teeth, in the fossil record. We just weren't looking closely enough. And if we were wrong about that, there's a place, a stretch of open water between Florida, Bermuda, and Puerto Rico where planes disappear. Ships vanish, without wreckage, without distress signals, without explanation. We've been told the answer for decades. Easy, rational, comfortable. But we said the same thing about Megalodon, and we were wrong about that too. That's where we're going next. Subscribe because the ocean isn't done surprising us.